everyone, it's Miss Maths 1. Today we're going to be looking at a grade 11 exponents and surds question. So I'd really appreciate if you could drop a like and subscribe, and let's get straight into it.
The sum we have is the square root of 10 minus 3 to the power of 2x is equal to 3 to the power of x minus 2. Now the question is solve for x. Now when we are given a question like solve for a particular variable, it means we need to isolate this variable within the question. So you can see somewhere here there's a 2x and there's an x. I need to find the value of it such that if I plug it in, my left hand side is equal to the right hand side of my equation. So for step 1, I'm going to get rid of the square root. In order to do that, we are going to do the opposite operation. The opposite of square root is to square. Now, in order to maintain the meaning of this equation, what I do to the one side, I have to do to the other side as well. So this is also going to be to the power of 2. Now, a square root and a square cancel. So that means I'm left with 10 minus 3 to the power of 2x on the left hand side. On the right hand side, I've got a binomial to the power of 2. So you can do a process of FOIL, whereby you say 3 to the x minus 2, and then you repeat that bracket. Because by definition, if I square something, it means I multiply it by itself this amount of times, right? 2 times. Now, what's starting to look a little bit messy is the fact that I have so many x's going on here. So let's try and figure out a way to simplify it. I'm going to do this using the FOIL method. First out is in as lasts. So we are saying 3 to the power of x multiplied by 3 to the power of x. That is going to be 3 to the power of 2x. By law 1, when I multiply bases, I can add these exponents. Now the outer terms. Negative 2 with 3 to the power of x gives me negative 2 multiplied by 3 to the power of x. Now the inner terms. Negative 2 multiplied by 3 to the power of x is negative 2, 3 to the power of x. And then the last terms in each of the brackets. Negative 2 multiplied by negative 2 is positive 4. Okay, and then the left hand side is going to remain the same. Now, what I think we can do is called case substitution. Now, case substitution works where I replace a part of the expression. So say we let 3 to the power of x be replaced with k. So the reason we do this is to simplify the expression. So we've got 10 minus. Now, if 3 to the power of x is equal to k, 3 to the power of 2x will be k squared. Okay. Here again, we've got 3 to the power of 2x. That's going to be k squared. Minus this 2. Here, once again, we see 3 to the power of k. So that's going to 3 to the power of x. So that's going to be a k. 2 to the k. Plus 4. Now the structure of this question looks very familiar. Somehow I think I'm going to work towards a trinomial. So let's get everything to one side. If we get everything over onto one side, I'm left with 0 on the other side. So I've got k to the power of 2 minus 2k minus this 2k plus 4. Now I'm still needing to carry these over. This positive 10, when we take it over to the other side, it's going to change signs. Negative k squared, when we take it over, it's going to change signs. So now it's positive. Alright, we are getting somewhere, guys. Now, identifying like terms. Here's a k squared and here's a k squared. Here's a term with a k. Here's another one. And then these are constants. Alright, let's simplify. K to the power of 2 plus k to the power of 2. we've got two of them. Minus 2k minus another 2k is minus 4k. And 4 subtracting 10 is negative 6. Look guys, that is a trinomial. We can see this because there's an expression with a variable squared, a variable, and a constant. Alright. What I'll do is I'll take out a common factor of 2 because 2 can fit into all of these numbers. So I'm left with k to the power of 2 minus 2k minus 3. Now I need to try and figure out what the factor brackets are for this trinomial. So dividing through both sides by 2, well, they will just cancel out and this side is still equal to 0. This side over here, by the process of inspection, if this is k to the power of 2, that means we need to have 2 k's, one in each bracket. Now a factor pair such that the product is equal to term 3 and the summation is equal to term 2, I could select the pair 1 with 3. Because 1 multiplied by 3 is 3, and I can combine these two to give me negative 2 if this is a minus and that's a plus. Alright, now this quadratic has two solutions. If these two components are multiplied to equal 0, either the k plus 1 is 0, which means it has a solution of negative 1, or the k minus 3 is equal to 0. So it has a solution of k is equal to positive 3. Okay guys, now the last step, we are going to undo this. So remember over here, we substituted this ugly 3 to the power of x with k. We need to undo that. So we've got 3 to the power of x is equal to negative 1. 3 to the power of x is equal to 3. Now, I want you to note this solution here. 3 to the power of x, no matter what the value for x is, the solution will always be a positive number. So for us to have an answer of negative 1, this is not applicable. Okay, so there's going to be no solution to this. So you could write not applicable or no solution. Alright, and then the last one over here, we see that we've got this 3 to the power of x, and here's 3. Now, if we are not given an exponent, it means we have an invisible 1. Now look at this guys, the bases are the same, so we can essentially just look at the exponents. Therefore, x is equal to 1. Alright guys, so this is going to be the solution to the sum over here.